Good morning. So we were discussing properties of acids, and I think only one property is left, and the property is acids reacts with acid reacts with metal oxides to form salt and water. Okay, acid reacts with metal oxides. In general, we can say metal oxides plus acid. Metal oxides, say it is MO, metal oxides plus acids gives salt plus water, gives salt plus water. Okay, as we have discussed, acid plus base, acid plus base gives salt and water. We have discussed now. This is also called as neutralization reaction. This is called as neutralization reaction. And now it is written acid reacts with metal oxides. Acids reacts with metal oxides to form salt and water. Same as base plus acid reacts with salt and to form salt and water. So here metal oxide, it is basic in nature. Metal oxide is basic in nature. So we can say metal oxide is a base. And we know base plus acid gives salt and water. And same here, base plus acid gives salt and water. Getting this? Not only this, metal hydroxide also, metal hydroxide, or we can say acid also reacts with metal hydroxides, to produce salt and water. Means what? Metal hydroxide, this is metal hydroxide plus acid, in general metal hydroxide plus acid gives salt plus water. Because metal hydroxide is also basic in nature, so we can say it is a base, and we know base plus acid forms salt and water. So both of these are true, that is metal oxide plus acid gives salt and water, and metal hydroxide plus acid gives salt and water. For example, say it is copper is the metal, and its oxide will be copper oxide, CuO. Okay, so I am writing here copper oxide. What is this? This is metal oxide. Copper oxide means it is a metal and its oxide is metallic oxide, plus acid, say it is HCl. Okay, then it will form a salt CuCl2, and water will be released, H2O. Okay, so add 2 here, it will give you CuCl2 plus water. So this is metal oxide plus HCl. In the same way, we can say metal hydroxide means CuOH whole 2. It is metal hydroxide, copper hydroxide, plus say it is HCl. Then it will form CuCl2. It will form CuCl2 plus H2. Okay. Now come to next topic. come to our next topic, and it is okay. So it is what do all acids have common in them? What do all acids have common in them? And I don't think there is any need to explain this. Okay, I have told you uh, different concepts regarding acid and bases. Okay, okay, and now you can simply answer it now. What do all acids have common in them? So all acids have hydrogen. Okay, all acids have hydrogen, which is common in them. Okay, so hydrogen is common. Hydrogen is common in all the acids. In all the acids. How to check? To check this, take number of acids. Okay, I am taking HCl, H2SO4, HNO3, H3PO4, CH3COOH. So many acids are there. Okay, I am just taking these acids. Okay. So when all these acids are dissolved in water, all these acids are dissolved in water, means we are going to make these aqueous. Dissolved in water means it will become aqueous solution. So I am writing it here, aqueous. Aqueous means all these acids have been added into water. So it produces H plus aqueous plus Cl minus aqueous. Produces H plus aqueous, Cl minus aqueous. It will produce 2H plus aqueous plus SO4 2 minus aqueous. It will produce H plus aqueous plus NO3 minus aqueous. It will produce 3H plus aqueous plus PO4 whole 3, sorry, PO4 3 minus aqueous. It will give H plus aqueous plus CH3CO minus. Getting this or not? So every time you can see H plus is the common thing. H plus is the common thing which is present in acids. Okay, which is present in acids. So what do all acids have common in them? So it is hydrogen, and not hydrogen, we will say hydrogen ion. Actually it is hydrogen, but when it is dissolved, when acid is dissolved in water, it gives hydrogen ion. You can see here H plus, H plus, H plus, H plus, H plus. So hydrogen ion, okay, is common in all the acids. Hydrogen is common, and the hydrogen is given out as hydrogen ion, H plus ion. Okay. Now one very important thing. Say it is HCl plus H2O. Okay, HCl plus H2O. Then I told you when HCl is dissolved in water, then HCl, this HCl, okay, aqueous, breaks as H plus aqueous plus Cl minus aqueous. I told you. And water, this H2O have a property of autoprotolysis. H2O have a property of autoprotolysis. It means what? It gets break into H plus and OH minus. Okay, leave this now. No need. Okay. Simply just try to understand here. It is H plus, it is Cl minus. And all these are present in H2O. All these are present in H2O. So what happens? Molecule of H2O combines with H plus ion. Combines with H plus ion like this. H plus plus H2O and it forms H3O plus. It forms H3O plus and it is known as hydronium ion. It is known as hydronium ion. Getting this? So H plus in water, as soon as H plus is produced, it readily combines with H2O molecule to form H3O plus, which is known as hydronium ion. So H plus, we can say H plus aqueous, or we can say H3O plus. Both are same. Both are same. So don't get confused. We can say H plus aqueous, or we can say H3O plus. We can say hydronium ion H3O plus, and we can say H plus aqueous. Both are same. Both meanings same. Okay. Now come to all acids, or we can say all substances containing hydrogen is not an acid. Very important thing. Okay. Means every substance containing hydrogen is not an acid. Okay. So right here, all substances containing hydrogen atom is not an acid. Is not an acid. All substances containing hydrogen atom is not an acid. What does this mean? You know, say it is sugar. It is sugar. Okay. So you know what is sugar? Sugar you have heard now. Okay. Many more things we can say. Say it is alcohol. Say it is C2H5OH. Okay. So here hydrogen is present in C2H5OH. It is actually ethanol. So in this you can see hydrogen atom is present. In this hydrogen atom is present. Again we have say CH3COOH. Again here hydrogen atom is present. So what? This ethanol and this ethanoic acid. This is ethanoic acid. Both are containing hydrogen atom. So if both are containing hydrogen atom, it means what? It is acid or not. So very simple. I have told you acids are those substances which produces H plus ion in water. Which produces H plus ion in water. It means if you will dissolve this CH3COOH in water means CH3COOH in water means you will make it aqueous, then you will get H plus ion. H plus ion along with acetate ion CH3CO minus. But when you will dissolve C2H5OH in water, you are not going to get any hydrogen ion. Getting this or not? So only those substances are acids which contain hydrogen atom and on dissolution in water produces H plus ion. Sugar contains hydrogen atom, but when you will dissolve it in water, it is not going to produce hydrogen ion, and that's why we say sugar is having hydrogen atom, but still it is not an acid. Okay, so we can check it that all substances containing hydrogen atom is not an acid. How to check? Very simple. Very simple. What to do? Say it is I am going to draw a diagram. Okay, a rough sketch I am going to draw. Okay, and in this, say this is like two rods are present here. Two rods are present here. Okay, and just it is connected with it is a bulb. It is indicating a bulb. Okay, and a battery is connected here. Okay, and willingly we can adjust one switch. We can adjust switch over here. Okay, say one switch is here. No need to take this. Okay, it is figure 1. Same figure I am going to draw here. Okay, it is bulb connected. Say it is negative terminal, positive terminal, negative terminal, positive terminal. Say this one is cathode, this one is cathode. Say this is anode. So we know anode is positive, cathode is negative. Negative is connected with negative, positive is connected with positive. Okay, cathode, anode. This is cathode, so positive, anode, so negative. And in this we are going to have say it is sugar solution. Here it is sugar solution is filled. Sugar solution is filled. Then you will observe this bulb is not glowing. This bulb is not glowing when sugar solution is kept here. Okay, Means circuit is not completing in this. Circuit is not completing in this. Getting it? This time I am going to take, say it is dilute H2SO4. Say it is dilute H2SO4, sulfuric acid. Okay. This time you will see the bulb is glowing. What does this mean? Sugar contains hydrogen. Okay. What is sugar? It is C12 H22 O11. It is sugar. And we have used here sugar solution. It is sugar solution, means sugar dissolved in water. So when sugar solution is used, okay, bulb is not glowing. It means circuit is not getting completed. It means this sugar solution is not an electrolyte, and I have told you acids are good conductor of electricity. Okay, aqueous solution of acid are good conductor of electricity. Why? Because aqueous solution of acid means it will give you H plus ion, and if you have ion to move, then it will conduct electricity. Here no ion is formed, that's why it is acting as insulator. Sugar solution acts as insulator. Okay, so bulb is not glowing here. This time it is producing H plus ion. Ions can freely move, so it will act as conductor and bulb will start glowing. Okay, now come to strong acids and weak acids. We have discussed, but it is in our topic. I am just going to remind you. So it is strong acids. Here it is strong, weak acids. At first, strong acids means which ionizes completely. Which ionizes completely. Okay, which ionizes completely. Weak acid means which do not ionize completely. Which do not ionizes completely. Means which ionizes partially. Which ionizes partially. Second point we will say, strong acids are HCl, H2SO4, HNO3, H3PO4, etc. All these are what? All these are strong acids. Why strong acids? Because all these, okay, ionizes completely, almost completely. Okay, and weak acids are carbonic acid, means H2CO3, and organic acids. Why? Because these ionizes but partially. 100% ionization, okay, is not occurring in case of weak acids. We can say if it is HCl, it is ionizing 100%. Means it will produce H plus aqueous plus Cl minus aqueous. 100 means HCl will break down into H plus and Cl minus, or HCl will ionize into H plus and Cl minus 100% completely. Okay, if it is H2SO4, then H2SO4 when dissolved in water means it is aqueous, again it ionizes 100%, means completely, and it produces 2H plus aqueous plus SO4 2 minus. So these are what? Strong acids. Now weak acids, say it is acetic acid, CH3COOH. It is acetic acid, okay, or ethanoic acid. It do not ionize completely. Means you have to remember, if it is not ionizing completely, then it will be a reversible reaction. It will be a reversible reaction. Means we will use here double-headed arrow. Double-headed arrow. Why? It is reversible reaction. Why it is reversible reaction? Because it is ionizing partially. So it will give you H plus aqueous plus CH3COO minus aqueous. It is also aqueous. Okay. Means some of the CH3COOH aqueous is ionizing into H plus and CH3COO minus. But at the same time, some of the CH3COO minus is combining with H plus to give back CH3COOH. Getting this or not? That's why the reaction is reversible. So here partial ionization is taking place. Partial ionization is taking place. So hope you have understand. Okay, very simple. Strong acid means those which ionizes completely. Weak acid means those which do not ionize completely or ionizes partially. Now come to bases. We have discussed bases in very depth. Okay. Now one very important thing we are going to discuss: alkali. So what are alkali? Alkalis are soluble bases. Alkalis are soluble bases in water. Getting this? Means all the bases are not soluble in water. What? All the bases are not completely soluble in water. Okay, completely soluble in water. But the bases which are soluble in water, okay, is known as alkalis. So we can say the bases which are soluble in water are called as alkali. Like sodium hydroxide, like potassium hydroxide, like calcium hydroxide, like magnesium hydroxide. All these are water soluble base. Means all these are alkalis. And alkalis are more important than bases. Actually, bases are alkali. Those bases which are soluble in water are alkali. But alkali have more importance than bases. Why? Because all of the, or we say most of the reactions of bases occur in aqueous solution. Getting? Most of the reactions of bases, acid and bases, okay, takes place in their aqueous solution form. That's why it is necessary, okay, or it is very important that a base is soluble in water or not. Okay. And one more thing, all the alkalis are bases, all the alkalis are bases, all the alkalis are bases, but not necessarily all the bases are alkalis. Getting this? Very important point. All the alkalis are bases, all the alkalis are bases, but not necessarily all the bases are alkali. It is very important. Now come to, what do all bases have common in them? What do all bases have common in them? And answer, you are knowing it now. Bases have OH, okay, OH minus ion. It is known as hydroxyl ion. Okay, bases have OH minus ion common in them. Okay, as acids have H plus ion common in them, in the same way bases have OH minus common in them, OH minus ion common in them. Examples are NaOH equals KOH equals COH whole 2 equals MgOH whole 2 equals FeOH whole 3 equals. It will give you Na plus Na aqueous plus OH minus aqueous. It will give you K plus aqueous plus OH minus aqueous. It will give you Ca2 plus aqueous plus OH minus aqueous, 2H OH minus aqueous. Okay, it will give you Mg2 plus aqueous plus 2 OH minus aqueous, and here you will get Fe3 plus aqueous plus 3 OH minus aqueous. So every time you can see OH minus is there. So bases have OH minus ion common in them. Bases have OH minus ion common in them. And you know, this is acidity now, I have told you. So acidity of OH minus, sorry, NaOH is 1, acidity of KOH is 1, acidity of CaOH whole 2 is 2, acidity of MgOH whole 2 is 2, acidity of FeOH whole 3 is 3. Okay. Now properties of bases. Properties of bases. So properties of bases, first property we will say bases are bitter in taste. Bases are soapy to touch. Bases are soapy to touch. Third property we will say bases turns red litmus blue. Fourth, bases are good conductor of electricity. Bases are good conductor. You have to keep in mind, when it is dissolved in water, then only bases are good conductor of electricity. Means bases are electrolyte. Means bases are electrolyte. Bases reacts with metals. Okay, next property we can say, okay, that bases reacts with we will say metals, and it gives hydrogen gas. Okay, say here it is base na. Okay, reacts with metal to give hydrogen gas. I told you acid reacts with metal, acid plus metal I told you. Okay, also it gives hydrogen gas, and in the same manner bases also reacts with metal. Bases also reacts with metal, not with every metal. Okay, not with every metal. Okay, but bases react with some of the metals to give hydrogen gas. For example, say it is sodium hydroxide is a base. Okay, it is a base. When it reacts with zinc, here it is aqueous, zinc is solid, then it produces sodium zincate. It produces sodium zincate, Na2ZnO2. Along with this, hydrogen gas is released. This is what? This is sodium zincate. Sodium zincate. Na2ZnO2, sodium zincate. Okay, getting this now? So bases reacts with metal, not with every metal, with some metals. Okay, to give metallic salt. This is what? This is actually a salt, and its name is sodium zincate. Okay, so bases reacts with metal to give salt and hydrogen gas. Salt is here sodium zincate, and hydrogen gas is produced here. Okay, so these are some important properties of bases. Okay, now in our next video we will be discussing properties of bases in much more detail. Okay, thank you.